Hey everyone, I'm Lisa Jones, and for my problem assignment or problem solving video, I decided to do a problem for my geometry course. The reason I chose my geometry course is because we use a building thinking classroom structure for our classroom and our curriculum. We've been working on this for the past few years, and I wanted to see how more students than just mine would handle a problem like this. So, and I know that my two other colleagues that teach geometry with me are very willing to try new things and then give honest feedback for how it went, um, and figuring out like where do we need to add missing parts. Um, Also, geometry is one of my favorite classes to teach. I love that it connects to the trades, and it was one of my first ideas when this project was introduced. The trades are something I grew up around, and a lot of my students are really interested in. So it's something that I have a better connection to, which makes it easier for me to teach. And then lastly, I was just in charge of chapter 3 and updating our curriculum to see if there's anything we can add or improve on. And this was a good placement because it didn't add a whole lot to my list, but it still got the job done for both this class and my teaching. The topic I decided to work with is understanding and labeling parallel, perpendicular, intersecting, and coinciding and skew lines. I chose it because it's coming up soon, and typically this is a very split subject. My students do really have in the past have done really good on um, identifying the in a picture, but then for like parallel and perpendicular because they know it. But then when I ask them to do it with an equation, there's just a disconnect that they're not understanding. And then in the reverse, like coinciding and intersecting, they don't quite understand in the image. So I'm really hoping, my goal as I created this was to merge the different pieces and hopefully eliminate some of that disconnect for my students. So that when they get to the assessment or all the pieces that they need to do individually without their group or without their classmates, they'll be able to do it on their own because they hopefully won't be mixing up the different parts or confusing them. So quickly explaining my problem, I said an architecture is designing a building shaped like a large rectangular prism. Inside the building, there are still steel beams that run along the edges, diagonals of faces, diagonals through interior to provide stability. A very simplified model of the building I gave them. I wanted to give them that image just so that they're not getting hung up on the rectangular prism, which they should understand what it is. However, we haven't covered all of the properties of it, so they don't know a whole lot about that part. So I wanted to give them that so that they could focus on all of those other definitions that we are going to be talking about in this section. I broke it up into 3 parts. My first part, kind of similar to how we have like our A, B, and C questions. That was kind of my thought process, just simplifying it a little bit. My part A was typically what students do pretty well with. However, I wanted to add in things that they couldn't necessarily see from my image. So the architect is considering reinforcing the building with the following steel beams. So then I have my beams listed. Some of them are shown clearly as segments. Other ones they would have to draw in and to understand them. Then I asked them to identify them as parallel, perpendicular, intersecting, skew, and to justify using definitions and vocabulary. I gave an optional sentence stem. I believe that this problem this activity is going to come after they get all of their notes. I'm not teaching them the notes. It's a lot of I give them information or they go find the information somewhere and then fill in their notes, and then they have to start applying it. So that's kind of where I'm expecting this project to go. I think this first part is achievable for everyone. It is new vocabulary, so that's going to be the part where I'll have them in groups of 3, and they'll be able to talk through their sentence and if are they using the definitions and vocabulary like they need to. I think this first part is very achievable for all of my students, but it will require a little bit deeper thinking. Now, the part where I see students struggle on is going from this concept of seeing and labeling to working with equations and being able to identify from the slope. So I wanted to add in that this is the same problem. However, they're going to be addressing it just slightly differently because now we're looking at only an XY plane and we are thinking about what's happening with those equations. So now the vocabulary words switch a little bit. Now we're working with parallel, perpendicular, intersecting, and coinciding. I made sure to tell them that they had to have the slope in their explanation. When they get to this step, so they need to do that part 1 first. When they get to this step, hopefully they can see they'll have already worked with the equations. They should know that to find slope, it needs to be in slope-intercept form or point-slope form. However, I prepared it for them to easily find the slope-intercept form so that they can go ahead, find the slope, and then the relationship that goes along with that. I think this part is also going to be very achievable for our students. I wanted to start off with easier equations to manipulate for beam 7 and beam 8 so that they're kind of understanding those. I also kind of put all of the slopes pretty similar to each other when they're simplified so that they're having to look closely at their positive, negatives, and reciprocals. Part 3 is where I think is going to be the most thought-provoking, and I will have the most people give up. So my part 3 is if we have each vertex, and I gave them the vertex in a 3-dimensional plane, and it's X, Y, Z, and then I labeled all those points for them. What would beam 6 from the previous problem, which is 3 over 2x plus 6, look like in the actual structure? And then I told them, keep in mind that there's no z in the equation. So this is going to be the most thought-provoking problem because they have never worked with plotting a 3-dimensional plane before. So I'm going to guess that that's where we're going to have a lot of questions of, okay, we can kind of, because we're only working with x and y in the equation, we can kind of ignore that third number. So that's why I gave that hint of keep in mind there's no z in the equation. As they have these questions, I am expecting them to panic, give up, or immediately ask a teacher for help. And I have a kind of like a list of like, okay, what should we be doing? I really want to utilize maybe answering it for one group, depending on the timing of when everyone gets to this problem, maybe telling one group like some hints, telling a different group different hints, and then telling them to talk to each other to see if they can figure it out. Rather than putting it all on me answering the same thing, because I typically have about 10 groups. And they will reach this all at different points, and I know that. If they are all at the same point, then I might say, hey, one person from every group, come talk to me real quick. I doubt that will happen. We might be able to do that in smaller groups. So if 3 of them finish, then are at this stage, I can pull those 3 and we can talk about that X, Y, Z. then they can go back and kind of think about, okay, if we ignore those last numbers, what does it mean? And I ignore E, F, G, H. I'm only looking at a rectangle. Well, rectangle is not that uncommon from a coordinate plane, and hopefully they start making those connections. I'm really curious to know, once they understand that, if they can figure out, why would I want a +6 in the actual structure, rather than just starting at 0. And I think they'll figure it out, because they like to climb on things. If there are things to climb on, they will. So I think they'll figure out that, like, hey, it's just a safety precaution. But that is my project. Hopefully it gets them thinking a little bit more. And I don't think motivation is going to be an issue for part 1, part 2. I think it's mainly going to pull in part 3, in which case I'm going to have to add some additional supports and also try to get them to the ending point. I think it's also kind of motivating. I purposefully only made it one question instead of looking at multiple of them, so that it's like, oh, you only have one question to answer. So hopefully that helps as well.